Hi everyone, this is Mr. Shields, and today I'm going to be talking to you about significant figures. So let's take a closer look at this PowerPoint that I have here for you. When we talk about significant figures, it's important that first we identify what the word significant means. We know that significant, another word for that might be meaningful. So scientists have created a set of rules in order to determine how many digits in a measurement are meaningful. I'm sure a lot of you recall typing in a series of operations into your calculator and you get this really, really long number back. And sometimes you'll ask your teacher, well, do you want me to round it to the tenths place? How many numbers do you want in my answer? Things like that. Well, scientists have created a series of rules to tell you how many digits should be in your answer, and we call those rules significant figures. What significant figures do is they tell us how accurate, precise, and valid our measurements are. And I'll explain that further with the rulers that I have here. Now, if you look at ruler number 1 and you compare it to ruler number 2, what you'll notice is that both of these rulers are measuring the same piece of tape, same object here. It doesn't really matter what that object is. But you'll notice that ruler 1 is clearly more accurate than ruler number 2. And so in identifying that, we know that the measurement we get from ruler 1 is going to be better than the measurement that we get from ruler number 2. And therefore, we might need to express these measurements a little differently. If I start with ruler number 2 and I were to try and give you a measurement, now remember, we always have to measure by estimating one place beyond what's marked on our ruler. And what's marked on ruler number 2 are our centimeters. So if you look at centimeters here, we've got 4 centimeters and we've got 5 centimeters. So I know that because it's larger than 4, but not quite 5, my first number is going to be 4 in this measurement. And I have to estimate one place beyond to make it a little more accurate. And I'm going to call this, well, it's not quite in the middle, so it's not quite 4.5. I'm going to call this approximately 4.4 centimeters. So that's going to give me 2 digits that tell me the length of this piece of tape or whatever it is. Now, if I come up here to ruler number 1 and I do the same thing, now you'll notice that the millimeters, here they are, 1, 2, 3, 4, all of these little hash marks are the millimeters. And so they're going to give me an additional piece of information. So now I don't have to call it just 4.4. I can call it 4.1, 0.2, 0.3, 0.4. And it looks like it's in between 0.4 and 0.5. So I'm going to estimate one further, and I'm going to call this probably about 0.8. So I would say that this is 4.48. And that's going to be a more accurate measurement because this is 4.48 here on ruler number 1. But here on ruler number 2, the measurement is only 4.4. So we know that significant figures become important. There would be 3 significant figures here, 4.48. Right? Those are 3 digits I've recorded. And down here, there would only be 2, 4.4. And so significant figures include all significant digits, we're going to talk about those in a second, in a measurement, plus a last digit that's estimated, just like I showed you here. And now if we continue over here, we have to follow these rules for which digits are significant. So when you determine how many digits or numbers are important, anytime you see the numbers 1 through 9, they're always significant, meaning they always count as significant figures. For example, 785 has 3 significant figures. Why? Because 7, 8, and 5 are all included in this number range from 1 through 9. So we know that this has 3 significant figures. As scientists, that's important for us to know how precise the measurement is. The more the significant figures, the more precise or accurate the measurement probably is. Now, as we go here and we look at this rule, zeros between significant digits are always significant. So if you see a 0 in between a significant digit like 8, we know that 8 is significant because it's a whole number in between 1 and 9. And we've got a 3 here. We know 3 is significant for the same reason. It's a whole number between 1 and 9. 1 and 9 also being significant figures. So we know that the zeros in between are always significant. So therefore, 1, 2, 3, 4, 5 significant digits are found here. And you could also call them significant figures. Sometimes scientists get a little clever and they shorten it and they call them sig figs. That's just an abbreviated way of saying significant figures. Now, let's talk about zeros that are at the end. We call those zeros at the end trailing zeros. So trailing zeros in a number are significant only if the number contains a decimal point. So here's my example. 500.1 has 4 significant figures, and it doesn't even matter if this one was a 0 and it's 500.0. All 3 of these zeros would be considered trailing and they would be significant. Whereas here, these zeros are also trailing, but the number does not contain a decimal point. Therefore, 500 here has 1 significant figure, whereas 500 decimal point, let's ignore this one for a second. If it was just 500 with a decimal point, that would be 3 significant figures because these 2 trailing zeros would count. And if I change this 0.1 to a 0, that would also be significant. Let's zoom out and look at some more examples, okay? So let's take a look over here at 6.0. Well, I know that the 6 is significant because it's a number between 1 and 9. We know that all of those digits, 1, 2, 3, 4, 5, 6, 7, 8, and 9, all of them are significant. It's the zeros that we're not sure if they're significant because sometimes they are and sometimes they're not. Well, we know that it's a trailing 0 because there's nothing after the trailing 0. And we also know that there's a decimal point present. According to our rules, we know that this 0 is significant, so there are 1, 2 significant figures here. And if we follow this down here, 6.00, these zeros are also trailing zeros. We know that there's a decimal point present, so they count. So 1, 2, 3 significant figures. And if we do the same thing here, there's a decimal point present, they're trailing zeros, they clearly count. 6.000, all of those digits count. Those are 4 significant figures. And if we bring it down here now, there is no decimal point present. Therefore, this 0 right here is not significant. And there is only one significant figure here. That significant figure is the 6. Let's take a look here at the 2,200. Think about it for a second. Is there a decimal point present? No, there's not. Are these trailing zeros? Yes, they are. If there was a decimal point present down here, that would be one story, but there's not. So these zeros, these trailing zeros, are insignificant, and there are 2 significant figures here. If I were to place a decimal point, let's see if I can do it. That is a terrible decimal point. That is a much better decimal point. If I were to look at this here, we've got 2,200 with a decimal point and a crazy line that Mr. Shields drew here. But because you notice the decimal point, these trailing zeros now do count. So now 1, 2, 3, there are 4 significant figures here as a result of the decimal point. So it's all about looking for the presence of a decimal point and understanding the idea of a trailing 0. The opposite of a trailing 0 might be something like this. These are leading zeros. They don't count. They're not significant, okay? Same thing here. All of these zeros are not significant. They're not trailing zeros. But you'll notice there's a decimal point present. And you'll notice there is a trailing 0 right here. So this 0 is significant. Therefore, there are 2 significant figures in this figure. 1, 2. And here, all of these zeros are located in between our whole numbers, so we know that they're significant. But what about this 0 at the end? I identify that it's a trailing 0. I look at the decimal point, and I establish to myself, okay, it does count as well. It's a trailing 0 with a decimal point present. So there are going to be 1, 2, 3, 4, 5, 6 significant figures present here. Now, we're going to practice this a lot in class. But this is your first introduction to significant figures. I also have another way of identifying significant figures that we'll talk about tomorrow on our video. But think about the importance of significant figures. Think about why we use them in order to validate accuracy and precision in our measurements, and how we apply them. We apply them by saying, okay, any number 1 through 9 is going to be significant. Zeros in between our 1 through 9 digits are always significant. Zeros out in front are never. And trailing zeros are significant only if there's a decimal point present. So we're going to practice this a lot. Hopefully that was helpful to you. Thanks for watching the video, and I will talk to you soon.